All right, so we're going to leave this to sales, right? The buzzwords?
I use buzzwords all the time.
I didn't mean to do that at all.
No, it's all
I
good.
I've had this one in my back pocket for like over a year, so I'm sorry.
It's all good. No, we appreciate it. We appreciate the time to come and like hang out with you guys and talk about a little bit of this. Right on. Who has heard of Snowflake? Okay, a few folks, maybe like half. And why am I? Oh man, I'm getting ahead of myself here.
You're such a PC guy.
I know, dude. I'm still getting used to it. So my name's Alex Woodcock. I'm a sales engineer with Snowflake, and I'm a new Mac user. This is my friend Scott. You want to introduce yourself?
Yep, so some of you might know me. I've been in this town for about 3 months. I'm the local sales rep for Snowflake Computing. Very exciting. We just had a couple of huge customers sign on, and really as Alex goes through some of the nuances, the most important thing that I emphasize as one of the dirty sales guys that overuses buzzwords and everything is that it's not an additional logo to further complicate an already very crowded space in terms of data, analytics, and accelerating insights. It's actually something that should very much simplify a lot of things, especially in the data science field for some of the reasons that Alex will go into, and become a standard as the engine that crunches a lot of data. So with that,
I just want to say that I do get sent out on sales pitches and I do use my buzzwords, so.
Right on.
So I'm sorry.
Cool.
there's no shame in it, as long as you know what it is you're doing.
Yeah. So we also talked about some of the data science memes. I think one of the big overplayed ones is how you spend 80% of your time worrying about X and only 20% of the time doing data science or what have you, right? Fill in the blank. And that some solution is going to come in and change that whole narrative. Have people heard that meme or that saying before? Yeah, it's kind of repetitive, but I get where it comes from. You know, it's the Pareto principle, and you want to actually like, if the way it comes back to Snowflake is that we want to enable you to not have to worry about the data pipelines and how you actually are getting data into Snowflake. We just want you to worry about how you query data out of it and how you make sense of it using data science tools. So Snowflake was born in the cloud, you know, as opposed to a lot of the other data warehouses that might be in the cloud today. But Snowflake was built and optimized for the cloud in order to take advantage of that elastic compute. And so there's one thing that you take away from this is that it's a different architecture than you might be used to, right? So you've got the quintessential sort of shared everything architectures, like an on-prem database, like a SQL Server or an Oracle, right? Where it's going to go and pull from all these different disks, right? And usually IOPS will become a bottleneck at that point. You have shared everything infrastructures like Hadoop, like data lakes, right? But then you're very tightly coupling your compute resources with your disk. And if you ever need to scale out or up, you actually have to scale them both together, right? And so Snowflake's architecture is unique in that it's what we call multi-cluster shared data. So in the middle there, you see centralized storage on any of the public cloud providers. And you have that one copy of the data, you'll get that automatic replication within the public cloud. In the middle layer, the sort of darker, I guess, middle blue region there, you see compute. So think of this like EC2 instances or Azure Compute or Google Compute resources, right? That are totally separate logically from your single copy of your data, right? So one copy of the data, you might spin up many different compute instances in order to then query that data or do analysis on it. The last one is the global services layer. This is really the Snowflake service. People will talk about the compute layer being the muscle, you know, and the storage being the blood of your system, but the services layer is the brain, right? And this is how we manage the data warehouse as a service and make all of that sort of overhead and data pipeline go away. So our mission, kind of getting back to brass tacks here, is to enable every organization to be data-driven, right? This could be every data scientist, this could be every business unit, but at its core, right, we want to take the pain out of data warehousing, right? And data science being a fairly new term, as we just learned, or probably already knew, right? We want to enable that and make that grow within every organization. So the current problem, we'll talk about 4 basic categories here. The first is siloed and diverse data, right? This is pretty common in the data science realm because you're thinking of both the structured tables that we all know and love, but also semi-structured data, and how do you actually take that data and munge it together or combine that data for a useful analysis. You think about being able to share data, especially at the organizational level, like how do I take this and give it to somebody outside of my four walls, right? Do I have to FTP it over to them or even just email it to them? That comes with a whole litany of problems in and of itself. The second are scale and speed issues, which you can probably already guess because we talked about that logical separation of storage and compute, but you can't scale that up or out very easily, right? You're sometimes having to buy more servers and install more software upon them and bolt them onto your instance. This can actually cause a lot of resource contention. So does anybody today manage the data pipeline and then have like BI people or analytics people trying to hit a data warehouse at the same time? Couple nods, maybe. So this is one of those problems that you won't be surprised to hear that we think we address. The next one here is complex and costly infrastructure, right? You're going to be up there and maintaining this on some day-to-day basis. There's a lot of care and feeding of a data warehouse that needs to happen, and you're often provisioning that for the high water mark. So the classic example is that on Monday morning, everybody comes into the organization, they want to read their reports to know what they focus on for that given week. But you have to size an instance for that high water mark, not necessarily whatever you need at that moment. So you'd be over-provisioned during the rest of the week. The three of these kind of fall into slow and limited decision-making, right? This is the whole value prop, right? How can you actually accelerate insight within an organization? How can you get people focusing on what's most important to them? So, oh yeah, we switched colors, right? This is on brand. So, unique architecture built in the cloud.
Good, orange bad.
Yeah, right? All your data in Snowflake can be centralized, right? We talk about this single copy of the data, and you can ingest both structured and semi-structured data. And using Snowflake's own data type called a variant, store all of that semi-structured data and then pull out whatever is necessary from that. So we see a lot of folks in the data science realm getting value out of that certain feature.
And all that interaction can be done with basic ANSI SQL.
That's true. Yeah. So Snowflake is a fully compliant traditional SQL interface. So if you ever need to query anything, or if you've ever taken a SQL class, you already know how to use Snowflake. The other one at the bottom here is to securely share data. This is a newer concept within the Snowflake architecture, but essentially being able to say, hey, you are an outside user who might need access to this. You never have to send it out of the Snowflake instance. You just designate them as a user so they can actually analyze it on their own. So just another benefit there. Unlimited, I always say that's a bit of a marketing term, but the whole phrase there being the size of your data or the size of your compute is the size of EC2 or Azure or Google Cloud. So you get to choose that and spin it up and down on demand once your data is in Snowflake. Simple, cost-effective infrastructure. Again, you already know how to use it if you know SQL, and then you pay as you use. So for every compute second or server second that you're using Snowflake to actually run any load, that's what you pay for, right? After you're done with it, you turn it off, you're not paying for anything anymore.
So as opposed to the other cloud providers that allow you to kind of go in and then manually say, hey, this is how many clusters I want and what size. What an administrator that's deploying Snowflake can do is say, hey, as we do this, I want an auto scale, which means that once the query comes in, and I'm not paying for anything because it's completely turned off, when a query loads up, it will spin up the clusters within the parameters that are limited, whether it's scaling up or scaling down. Run those queries, and then once those queries are done, scale back down and only pay for the spike that you use. And that's one of the most significant use cases, especially if you're doing any sort of white labeling, embed, or people in certain departments are doing chargebacks. Like, hey, we like the analytics department, but we're not going to pay for what data science uses, or the other inverse of that.
Right. So all of this kind of comes, oh yeah, question.
Yeah, I just had a question. So you're saying that it can interface with SQL queries and everything. So is it predominantly, I see it's structured and semi-structured, so I would assume it's object-oriented as well as relational database?
Yeah.
Within it?
I mean, everything sort of gets ingested as a structured object, right? You put the semi-structured data in, and then you can query it as a structured object.
Okay, so I could just use a SQL query and then get it back objects or something like that, like
Yeah.
JSON objects and stuff.
Exactly.
The other question I had too is regarding like the multi-cloud and scale and speed kind of concept.
Sure.
Can you have a deployment simultaneously on 2 different clouds and then have them replicate synchronously or
Yeah.
asynchronously, I guess?
Yeah, that's a great question. That was actually a feature that was announced at our Snowflake Summit conference that happened a couple months ago or so. It's in the private preview right now for some of our like big customers who are going to need that, and they don't want to have that vendor lock type agreement. But it should be GA'd, I want to say by the end of the year or maybe first quarter next year.
And theoretically, you have them replicating and then have them all independently scaling and downscaling? on
Sure,
their own
yeah, as long as
cloud?
whoever was administrating that given account or instance, yeah.
That's pretty
yeah.
cool.
I think that the end goal of that is not only a feature, but it should be part of our standard for disaster recovery.
Mm.
Say like the unthinkable happens to Amazon, you're already replicated in.
I was thinking it kind of keeps like pricing in check too. Like if you ram everything into Redshift or ram everything into BigQuery, it's like, okay, well, I'll just go to Snowflake and then,
Yeah.
just go with it, it's cheaper.
Right.
Sort of keeps everybody honest.
For the storage and everything, it's, all this is public and we get $23 a terabyte a month. I mean, it's so nil compared to your actual computing costs. Whenever we get involved in any form of like commercial piece of it, we treat the 3 partners like pretty much equal. I think really the only distinction at this point is that people have already either preferred AWS or Amazon, or Microsoft, and then at a lesser extent for business purposes, Google. We're just opening up our Western Microsoft soon, like our current place is running out of the Virginia East area.
Yeah.
Oh, you mean like a camp, like Snowflake campus or something?
No, like the actual
Sorry.
storage of the data.
The
Oh.
instance, the
Region.
deployment of Snowflake, yeah.
Gotcha.
So right now it's in select regions for the given public cloud providers. Right now, the main Azure deployment is what Scott's saying is over on the East Coast, but we're
Gotcha.
going to be deploying our West Coast one here in the next couple months. So kind of bringing this back to the solution here, right? It all results in what we call, faster, better decision making. That's the end goal, right? Is that you're able to be agile and adjust and make these changes on the fly. So just to kind of put it, what we've been describing here into an image, right? This is sort of the traditional architecture with an on-premise data warehouse, right? So you might have Teradata, Vertica, Netezza. You might even use an OLTP system like a SQL Server, Oracle, or something like that in the middle. But we've seen data lakes become very ubiquitous. With the advent and rise and eventual fall of Hadoop. But you see data science there in the bottom right, usually pulling from the data lake, sometimes from the EDW as well, in order to do these analyses. Other use cases over here, right? You can see things like test dev. So Snowflake has a feature that we call a zero-copy clone. So if you ever wanted a piece of a database and to replicate it immediately, you can actually just create this copy of it without an actual replication. It creates new pointers towards the copy of that data, and it will store the delta of that. And then you have your kind of normal BI and analytics use cases that we're working off of data marts, usually to avoid that kind of concurrency problem, right, where people are all coming in at the same time. So you're isolating those workloads with physical data storage. In the modern architecture, right, Snowflake in the middle, great, awesome. And any of those data science tools that you see in the bottom right, anybody use those? Like Spark, Python, R, Dataiku? Yeah, absolutely. So all of these have native connections, ODBC, JDBC connections into Snowflake. So you just pull data from Snowflake and you're kind of off to the races. But
Did the lake disappear?
the data lake did disappear, right? Because we, in our model, right, you're ingesting all your semi-structured data into Snowflake and then able to then query it as structured data out.
So there's no structure you can map onto it, and you don't pull that in?
Sorry, say again?
Okay,
Yeah, so if we're talking audio, like video data,
okay.
Yeah.
right. But with the way that it's designed, your XML, your Parquet, your JSON, all of the commonly available.
If you can derive a structure from it.
Right, and
Correct.
so it's natively done inside of Snowflake, then makes it available in terms of ANSI SQL and a columnar relational database, and then we have native connectors to all of your major data science tools as well as BI tools, like our biggest partners are Looker, Tableau, all those guys, et cetera, as well as them. And then if you're working with something that's kind of, not necessarily off the shelf, as Alex mentioned, ODC, JDC.
Yeah. So just to paint this in one more light here, right? We'll talk about the middle as being, again, S3 or Azure Blob or Google Storage, and you have these compute clusters that are represented by those gears, right? So if you have a data science use case that is sometimes getting relegated to the weekends or getting relegated to the wee hours of the morning, you might actually take that compute cluster and you might spin it up, right? To just give yourself more compute power in order to complete a job that much faster. In the same realm, for people who are ELT or ETL developers, you can actually turn on a compute cluster in order to load data into Snowflake, and once you're done, you turn it off. Okay, so you're not paying for loading data anymore. The last use case is that concurrency-based model. So if you have a lot of people coming in on that Monday morning, Snowflake can actually scale out, and you would set all of these thresholds and parameters for when Snowflake would actually scale out in order to handle any queued requests. But the whole point of this is that this is all on demand once your data is in Snowflake. It's all in this interface, or it can even be scripted via SQL commands to say, I want to alter this warehouse to make it, our warehouse, our compute cluster, to be twice as big, and then I want it to spin back down after 5 minutes or 10 minutes or what have you. Again, not paying for it after that. So, again, just to look at the data science tools, I do have to put up the NASCAR slide just to say, we have a lot of customers and we're growing. I wanted to pick out a couple data science use cases. One is from Overstock. I linked it here in this presentation, but if you're not familiar with Overstock, this is just a retailer that wants to sell excess product that is brought to them by third-party vendors. They had a Hadoop data lake infrastructure as well as their on-prem data warehouse. I think it was Teradata. It was costing them a lot of cycles in order to be able to deploy new models and push them out to the business in order to change their pricing around. After with Snowflake, they have a single source of the data. They increased collaboration across the enterprise, and they're actually able to deploy now at a one-day clip, which greatly increased their bottom line. So just wanted to talk about that customer story. There are a couple other data science ones that are pretty heavy. Nielsen, the TV ratings organization, they're collecting all that viewing data and taking all that survey data to your household, right? They would have to aggregate all that and provide it back out to consumers. Or another one I heard was about a gaming company called Kixeye. If you've ever played things like mobile games where they have transactions in the middle of it, microtransactions, they were running models to actually figure out where to optimally place those bundles and models or add-ons and things like that. So a little maybe a nefarious data science use case, but one nonetheless. It's something to help their bottom line. I'm not going to go into a full demo of Snowflake today. Happy to do that when we're slamming beers or shots or what have you, or if you're curious about that. But just a couple quotes to leave you with from the Overstock guy, Craig Kelly. Again, sources and customer story is linked there. And going back to that 80-20 principle, right? He didn't have to focus on the data pipeline anymore. They're doing more valuable work at the data science level. And that's it. There's a couple of engagement models. That's more for the commercial side of things. But we're happy to take any other technical questions that you might have or just questions in general.